Hey everybody, we have a lot to get through today, so buckle up. I'm going to try to do this as fast as possible. Today we are talking about integers and rational numbers. And to get started, we're going to review the definitions of different types of numbers. The first type of number we're going to talk about are natural numbers. Natural numbers include 1, 2, 3, 4, 5, and so on. These were the first numbers developed by primitive people, numbers used to count grain, livestock, other crops, stuff like that. Next, we have whole numbers. Whole numbers include all of the natural numbers, but also 0. Whole numbers are numbers that you would use to answer a question like, how many apples do you have, right? You can have 3, you could have 2, you could have 1. You could also have 0. Integers include positive whole numbers, negative whole numbers, and 0. So basically anything that isn't normally written as a decimal or a fraction is considered an integer, whether it's positive, negative, or 0. Finally, we have rational numbers. Rational numbers include any number that can be written as a fraction. Any number that can be written as a over b, as long as b does not equal 0, right? Because we can never divide by 0. This includes numbers like negative 9 over 8. Could include something like 0.6 repeating, because that's equal to 2/3. Could be negative 1.75, because that's equal to negative 7 over 4. Could be positive 6, because we could write that as 6 over 1. So anything that we can write as a fraction is a rational number. There are examples of irrational numbers, numbers you can't write as fractions. Irrational, I won't type this one out. So irrational numbers are decimals that continue forever but don't repeat. So for instance, pi is an irrational number because it's 3.1415, etc., off to infinity with no clear pattern. So there's never a way to write it as a decimal. Other examples are some square roots, like the square root of 2 is irrational, the square root of 5, square root of 7, a lot of numbers like that. All of these numbers fit into what we call the real number system. The real number system consists of all of the numbers that we see in the real world. We have all of the real numbers in this box here. Now within that box, we have the rational numbers, right? That's a smaller group because that's only the numbers that can be written as fractions. Within that group, we get even smaller. We have integers, right? Integers are positive and negative whole numbers plus 0. And then even smaller than that, inside integers, we have whole numbers. Just the positive numbers that we use to count plus 0. So all whole numbers are integers, all integers are rational numbers, and all rational numbers are real numbers. Let's get some practice classifying these numbers in their different groups. So I want to know if 5.6, negative 2 2/3, and negative 24 are whole numbers, integers, or rational numbers. So we got 5 at 0.6, got negative 2 2/3, and we have negative 24. So is 5 a whole number? Yes, it is. I'm going to put W for whole number. Is it an integer? Yes, it is, because all whole numbers are integers. It's a positive whole number. It's a positive integer. And is it a rational number? Yes, it is, because I can write 5 as 5 over 1. So it's also rational, right? We can write that as 5 over 1 to show that it's rational. 0.6, is that a whole number? No, it is not. It is an integer. No, because it's not a positive or negative whole number. Is it rational? It is, because I can write 0.6 as 3 over 5, right? I can write it as 6 over 10, simplify it to 3 over 5. So because I can write it as a fraction, it is rational. Negative 2 2/3. Now I know it's not a whole number because I got a fraction in there, so It can't be an integer also because it's not a negative whole number. And can I write it? It's a mixed number, but I could also write it as an improper fraction. 3 times 2 is 6, plus 2 is 8. I can write it as negative 8 thirds. So we know it's rational, and negative 24. Is it a whole number? No, it's not, because it's negative. Whole numbers are only positive and 0. It is a negative whole number, though, so we know it's an integer, and it's rational, so I can write it as negative 24 over 1. Now, let's say we wanted to order these numbers from least to greatest. That can get kind of tricky when we're working with numbers that all are in different forms. We got some whole numbers and integers, we have a decimal, we have a fraction. The best way to do this is by converting them all to the same form. And the best form to have them all in for comparison, I think, is as a decimal. Because if we're looking at fractions, to compare them, we got to have common denominators, and that can be tricky. So if I write, my numbers are 5, I have 0.6, negative 2 and 2 thirds is going to be negative 2.6 repeating, and I have negative 24. So to put these in order, from least to greatest, I want to start with the least. So I'm looking at my negative numbers, because I know my negatives are always going to be less than my positives. Now I have 2 negative numbers here, negative 2.6 repeating and negative 24. If I plotted them on the number line, negative 24 is going to be pretty far to the left of negative 2.6 repeating. So negative 24, that's a lot less than negative 2.6 repeating, which is less than 0.6, which is less than 5. So there I am, from least to greatest. Let's try one more like that, and then I think we can call it a day. Let's say I have negative 2, negative 11 over 5, negative 7 thirds, and negative 5 over 2. So these numbers are all pretty hard to compare because negative 11 over 5, negative 7 over thirds, I might not really have a good idea of what that means. So I'm thinking of rewriting these. If I rewrite these as mixed numbers first, then I can rewrite them as decimals. I know 5 goes into 11 twice, and I'll have 1/5 left over. 3 goes into 7 twice, and that would be 6, so I have 1/3 left over. And 2 goes into 5 twice, so I have negative 2, and I have 1 left over, 1/2. So this is still a little weird, but it's becoming a little bit more clear that these numbers are all going to be pretty close together. So negative 2, now I know 1/5 is 0.2, negative 2.2. I know 1/3 is 0.3 repeating, and I know 1/2 is 0.5. So I'm looking at these three numbers. I want to go from least to greatest, and my least number here is negative 2.5, because that's going to be the furthest left on the number line. So negative 2.5 comes first, and then we have negative 2.3 repeating, negative 2.2, and our greatest number in this whole group is negative 2. So it's actually the exact reverse of the order I originally wrote it in. But this is our order from least to greatest. Now I want to write these numbers as they originally were. Negative 2.5, that's negative 5 over 2. That comes first. Negative 7 over 3. Negative 11 over 5. And negative 2, our greatest number. So here's our answer from least to greatest. All right, I know that was a lot. Thanks for bearing with me. I'll see you guys tomorrow.